I lost the footage of the fabrication of this one. I don't know where it is. It might be somewhere on my computer. I can't find the files anymore. I know they were there. So that footage will be replaced by making the smaller one. I just need some smaller stock here. So in part 2 it will be the machining of the bore and the other bits rather than seeing the fabrication. Sorry for that, but I must have done something wrong. I don't know what. So what we try to achieve is a center here. I use the rotary indicator and just look for the lowest spot, and we're on the flat. And that should be center. Bump it a little bit up. It's within a couple of hundred, so I'm happy with that. So now we know we are on center here. If we got the same distance from the center here and here, we don't need to measure at the bottom because we know we're already on center, because that is 30 millimeters wide on all surfaces. So now we're gonna lock the table and the knee as well. So machine is locked, power feed is disengaged. We put a center drill in, give it a quick eyeballing if it makes sense, and then we're going to drill a hole which is at least as big as the shaft of the collet shank here, because that's going to stick out about that. So we will drill a hole here and bore a hole for the bearing. I've got a DRO on the x-axis, but it's one of these cheapo things. It's not super reliable. So I'd rather do it this way. These rotary dial indicators, they're fantastic. I never saw them here until I watched some videos of some of the American guys, and it's just a useful piece of kit. The problem is they need a lot of space, so on this machine you may have some fun. So, center drill. So we're good to go. Knock the table up a little bit, and from eyeballing it's pretty much in the center. We got enough travel, so let's fire that thing up. Never trust yourself, because if you're that far, you don't want to start again. So from eyeballing it looks like center as well. So let's put a center in there. start with a 10mm drill, so we don't need to switch the collet. That key is really good. The problem is it's a lot trickier to align than the normal hook spanners. What the hell is that? I'm happy with that drill. Either the stuff is hard from welding or the drill is just rubbish. I bought a whole bunch of drills. That's quite possible this is a SS drill for wood. I haven't screwed anything up here. Come, get out. It said HSS, but it's completely shattered. So yeah, we may have some issues with hard material from welding. Okay, we need some better drills. We could plunge in with a milling cutter eventually. I think we do that. Just plunge in with a milling cutter. It makes a huge difference. This nut got a bearing. Got a bearing in the nut, and it's a much more positive tightening feel there. So let's see where we're at here. It's slow, but my fear is that the hole is already distorted. That's the reason why I use a milling cutter. So we're still in center. Even that drill may have some, that caused some distortion. Well, left on the machine, but it doesn't cut. Yeah, I know why. The cutter doesn't cut in the middle. At least our hole is now centered again. You can screw up a job as long as you find a way to recover. This is a 12mm cutter. So need some 30mm drill. I think we got our center hole back. That should clear the it's big enough to clear the shaft as well. But that should be good to go. So we set up the boring bar and we already went in once, and now we're gonna advance the boring bar a little bit. But for whatever reason I lost my Allen key. Gone. I've got the depth indicator here. I think it's not visible on that Noga, well, pseudo Noga. That's my depth stop, and we're heading for 26 millimeters. We got 2.5 millimeters to go, so let's take 1.5 tenth. So just need to lock the boring bar, otherwise it's gonna go wherever. So we should now be good to go for another 300s. So that's up. Okay, let's double check. Take another 2000 out. So much, it's a bit of stick out here, so I'd rather be careful. So that's another 0.6 on the diameter, maybe. I'd rather be a little bit careful because this tool is grabbing a little bit, so we may take too much, and I don't want that, because there is another bearing size available, but it's not necessary to did I lock it? Yeah, I did. So it's pretty cold today. We had about -2 in the workshop when I came in before. So I'm gonna turn the heater on very soon, so it's gonna be noisy again. So let's see where we are. So now it's 200. I'm being generous, I'm taking 3 times 600, 6/10 of the diameter. Seems to work okay. I'm talking millimeters here. Sorry for you imperial guys, but I'm used to deal with millimeters, so it makes my life a bit easier. Because whatever I tell you in imperial is wrong anyway, so I try to deal with it, but the material is very strange. It's got some hard spots from welding, so gotta be careful here. Anyway, there. So let's see where we're at. Probably running out of travel in a minute here. It's 2581. I'm heading for 26. I think we do a spring pass and see where we are. That's just a spring pass with no feed whatsoever, and it shouldn't be far away. You've got to be careful because it's extremely cold here, so make it right to size now. It's probably too big while it's warmer. Sorry folks, it's gonna be noisy. The heat at the moment. According to that, we're right on the money. That is surprising, yeah? Apparently that should fit now. Check that. Let's do another spike pass. And we are probably there. I'm a bit worried that if it's normal temperature, this thing might be too big. So that should be it. Right in. So that's fine. So cold, the heat doesn't stop. I ordered a little bearing, which is a double row bearing. That's the reason why I went a little bit deeper. Should be good so far. So we turned it around. So what I did was indexing on that surface, because the mount is not 100% same on both sides. I was indexing it, turned it around and set it to the same, because these surfaces are concentric to the holes. So the plan is actually drilling the center hole, mill it off and make it flat, and then we go to the lathe and make it round. That's where we're at.